Hello, so we are back, and this time we have a nice all-in-one computer to repair. Now, from where this all-in-one computer come? You remember that guy where I was fixing his boards on a live stream and he called Domino's and ordered a pizza? It's the same guy computer. So let's try to help him. First, let me plug it in and let's check. The problem is no sound. So it's working fine, but no sound. What he did, he ordered the speaker, he replaced the speaker, but the sound still not working. Let me power up this computer. And the computer is coming on, but we have no keyboard, yeah? Let me plug a keyboard. Actually, it's working without the keyboard. I just plugged the mouse. We have a brand new Windows here, and we don't have like any sound, like nothing. I mean, we should have sound in this moment. So clearly is no sound coming from this computer. I will say, let's not set up the computer. Let's open and have a look inside. Okay, and we open the back cover. Let me remove the shield. And we remove the shield. That's a nice motherboard. So we have like a normal hard drive, and also we have a M2 drive here. Now, I suppose this is the speaker connector. What we're expecting around 8 ohms on the speakers. 4 to 8 ohms. And we have 4 ohms on this speaker, and we have 4 ohms on this speaker. So the speakers are good. Now, in order to fix the sound, you have one option. Yeah, you don't have to. So one, you replace the audio chip, which has the digital to analog converter, and also the audio amplifier. And that's all your options, yeah? Because if it's not the audio chip, audio IC, or audio chipset, it's actually the Intel chipset. The audio IC is speaking directly with the chipset. It's a driver problem now, not on 2024 with these new computers. So the Windows comes with a generic driver, and the audio should work. Now let's check under the microscope. And here we have the audio chip. What we can check on this chip, we can check if it has voltage. Most likely has voltage, but that's something what we can check. So let me plug the charger. The charger is plugged in, pressing the power button, and the computer is on. Let's check the voltage on that chip. So the voltage on this chip, and you can clearly see you have here like an inductor, you have capacitor. So here must be the power L, and this 5 volts, 5.1, you can see. So the chip probably is dead. Nah, it's cold. It's cold, but nothing else. What you can check more, let me unplug the power. You can check if the speakers are reaching this chip. So all amplifiers from laptops, they are bridge amplifiers, yeah? So the speaker are not, it's not coming like, okay, one wire, the speaker is to the ground and one is going to a capacitor. No. So both speaker wires are going to the chip. And we are looking for two capacitors, but we are looking to go straight inside of the chip, yeah? For the speaker wire inside of the chip. You know what? I can't see the speaker coming to this chip. Let me beep with the speaker. And no, it's not beeping. I mean, I have one probe. I have one probe here. Yeah, that means we should beep at least 2 pins. And this 1 second. Oh, okay. Okay, my fault. Sorry. So this PC has 2 different. No, I was wrong. I was wrong. Not sure what is this. You know, can be related with the card reader or with the network controller. I have no idea. But this chip is near to the screen connector. You can see this chip is near to the speaker connector. So clearly, this is our audio IC. And the speakers are coming. Let's see. So we have one here, one here. No. One here, one here. No. One here. Yeah, we have to find out if the speaker is reaching this chip. So one wire is coming here. And the second wire is coming here. Okay. And the other speaker, one wire is coming here. And the other wire is coming here. So the speaker, it is reaching this chip. So this is either the audio chip or only the audio amplifier. And the other chip is something else, is the one which is speaking with the chipset. Not sure. And that's not my problem. I will not spend more time in this. So I'm assuming this chip is dead. Yeah? We have to replace the chip. No, actually, let's check the voltage on this chip. On this chip, we didn't check if we have any voltage. So the power is plugged in. The laptop, the computer is on. And on this chip, we have... Where is the power? Probably here. Yeah, here. And on this chip, we have nothing. Lol, we have no voltage on this chip. I mean, this cannot work without the voltage. So check here, yeah? You can see, same like with the other chip, yeah? Pay attention here. Capacitors to ground, and you have an inductor, you can see. And from this inductor, I should have voltage, but I have 0 volts. Can we do a dodgy things? Yeah, I can strap this to the other chip 5 volts. And probably that's what I will do. I mean, what can be faulty? Probably this kind of MOSFETs, you know, which is switching on and off the audio. And I have no idea where it can be. So we can use one wire from here. Yeah, you can see 5 volts, and yeah, we tie this to 5 volts. I'm assuming it's 5 volts, can be 3.3 also. Not very likely, but can be. Can we check with something else? Yeah, we can check with the power supply, yeah? So let me lower the voltage. Let me see what it's doing with 3.3. 3.3. Let me lower the current. Yeah, too much current. So we are powering the audio IC. Lol is short. I mean, that's great. This is short. Check that. Check here. The voltage get dropped to 0. It's short. I mean, it's short. Let me unplug the power. Let's check one more time. So one more time. Comic with I'm doing something wrong. Maybe no. The plus cannot be here because we have the inductor. So this is plus. So here it's taking like 600 milliamps because that's the limit. And the voltage is 0.1, very low. So let's higher the current. 1.6 amps, and we have 0.5 volts. So with this current, we should see some heat. Let me grab the thermal camera. Something is bad here. I mean, it's short. Okay, we have no voltage. And, you know, the computer is still coming on. So that power rail, which is shorted, I'm assuming that's not the only fault. We can have like a second fault. So let's see. Coming with current here, 1.6 amps, and what is getting hot. Wait, nothing is getting hot. Huh? This is a miracle. Yeah, the chip is taking current and we cannot see the heat. We have like 0.9 volts with 2.6 amps. Definitely we should see. Maybe there on the other side of the board. Okay, this is a little bit crazy and unexpected. I never seen something like that. I mean, clearly here on the other side of the board, something is getting hot. Check there, check there. You can see. So I will say, let me take the board out because, I mean, it can be the regulator or the MOSFET which is sending the voltage to this chip, or can be a capacitor shorted to ground. I can easily remove that inductor without taking the board out. I can remove that inductor and supply power from this chip from 5 volts. But you know, we know the guy. Let's try to make it right. Dodgy as possible. That's mean cheap as possible. But let me take out the board and let's have a look. I mean, I'm just curious because otherwise I just disconnect the inductor. I'll use a wire from here to here and job is done. You know what I mean? But you will call me dodgy. So let me take the board out. Okay, and the board, it's out. Can you spot anything? Okay, this board looks more complicated on this side. Yeah. Check here, yeah? So where was the hit? You remember? It was here somewhere. Now check that chip there. You can see it? Basically, it's exploded. Let me take down the computer. I think the situation just complicating itself right now. Yeah, it is more complicated than I thought. So this is a freaking power supply, you know what I mean? It's not like supplying power to the audio AC. I mean, this is doing more than that. We have a coil, actually. So the output is shorted, right? Must be shorted, but we can check that. Output 1 ohm, you can see. So it's 1 ohm because the chip is shorted. You remember we seen heat here. And I'm kind of happy I didn't I didn't bridge the chips because clearly this chip is working with different voltage, most likely 3.3 volts. But anyway, I will check before I will bridge something. I will check with the power supply to see the current with 3.3 and what happened with the current if I raise the voltage. So yeah. Okay, let's check this chip out. I'm not sure what chip it is. Yeah, it's welded. You can see it's welded. And the chip is out. Yeah, welded, you can see. Good. What about now? Now we have any short on the output? Let's see. So on the output, we have no short. You can see no short. No short. And you'll say, yes, sorry, but now we need a power supply. Yeah, this is a power supply which is not supplying power only to the audio IC. Clearly, you know what I mean? This is a big power supply. Now, what this power supply is doing and what voltage is supposed to be here? That's a very good question. I'm assuming it's 3.3, but you cannot move forward just assuming. What chip is this? APW7301? APW7301. Let me check. Okay, we have some problems. So I found the chip, but the chip actually, I'm looking for the output. What is this chip is providing? But this chip is able to provide from 0.925 up to 20 volts. So we have no idea what voltage is supposed to provide. Replacing the chip now, we don't have something like that. Let me see how the voltage is adjusted. Based on what? Okay, so I'm assuming with the feedback loop. Yeah, the voltage is adjusted with the feedback loop. And you have V out, check here, yeah, V out. Let's go blind, yeah. So I say is the 3.3 volts. If it's the 3.3 volts, we cannot check the coil. I mean, we can, but it's more complicated. The capacitor more complicated. But we can check R1, which is here, which is a feedback resistor from the output. If the R1 is 24 kilo ohms, that means this power supply is 3.3. Then you have a resistor to ground. If it's 3.3 volts, the resistor, the R2 should be 9.1 kilo ohms. Yeah. And also we can check R3. R3 is about the same. Oh, R2 is the same. Yeah, so only R1 is different. So 3.3 volts, 24 kilo ohms. Let's check. So the feedback resistor is from the output. So this is the output, and it's coming here, and we have one resistor here, this one, yeah. So this resistor is 80. This resistor is. Wait, what's going on here? This resistor is. We are getting a capacitor charged. What capacitor? There's no capacitor here. Probably from here to here we are charging the capacitor. Not sure. I mean, this resistor, I have no idea. Check that. It's going up to 70, 80 kilo ohms, 90, 100. And it's keep going. Okay, that's a little bit crazy. And the other resistor is this one. Okay, let me change the scale. So this resistor is 9.2. Yeah, about there. It's still going up. That's crazy. I mean, I can't check this resistor. And now I can't check anything. Yeah, 9.1. I believe it's 9.1. And this one, I believe 9.1. Wait. No, I think I'm getting old. I mean, why I cannot check one resistor? Yeah, it's going somewhere else. Check that. Yeah, must be a capacitor here. Because I'm pretty sure I'm checking the capacitor. Okay, that's fine. Yeah, it's okay. Don't worry. But this is a pretty nice power supply. I mean, the chip is quite smart build. Pretty simple, and you can output any voltage. No power good, right? No power good, only enable. Perfect. Now let's check that resistor. So this resistor real value is 120 kilo ohms. I can't believe actually I don't have 120 kilo ohms on my chart. How this can be 120 kilo ohms? Because I don't have it here. I'm doing something wrong. R1 kilo ohms. Yeah, typical application for 3.3 volts. Yeah, that's a nice chip. Check here. It's so simple and efficient, obviously. I'm missing something, or why do I have such a big resistance? I mean, bigger resistor here means lower voltage on the feedback. That means the output will be higher. So what is the output on this case? 1 second. So yeah, you can check that. Yeah. So higher the resistor, higher the output voltage. So basically, for 100 kilo ohms, we should have probably around 12 volts, right? 12 volts on a board? Huh? Okay, let's try to see about that audio chip. Maybe we can figure it out what voltage is there. ALC 1301H. Let me see what I can find about this chip. No, we cannot find this chip. So what we are doing? ALC 1301, we cannot find it. Based on what we've seen here, the power supply should be like 12 volts. But how we can be sure? Huh? I mean, if it's at 12 volts, then this power supply is supplying power actually only to the audio amplifier. Do you think this power supply is supplying power to a different chip? Let's try to find out before doing some stupid things. You know what? I cannot find something else where the plus track from here is going. It's very possible that power supply actually is supplying power only to the audio IC. Audio amplifier. I'm pretty sure this is only the amplifier. So this is actually the audio chipset, and actually this is the amplifier. Okay, that's fine. That's okay. Then we try to go like the right way, yeah, the professional way. Didn't work. So we have to try with the power supply and find the rough voltage. I mean, even if the voltage is lower, okay, we don't have 5 watts output, we have 4.5. Doesn't matter. So let me put the board back. I'm happy I disconnect the chip. Yeah, no, I'm not gonna replace the chip this video. Maybe on another video. Let me put the board back. Okay, so the board is back. Let me plug the power. Plug in the power. Fine. Pressing the power button. Let's see if we still have picture. I mean, we should have picture. That chip doesn't have a power good pin. But let's be sure about that. We have picture. That's great. That's great. Now let me set up my power supply. Ground. We need low current, and it's too high. Let's lower the current. Good. And we are coming. Let's start from like 1 volt here. 1 volt is taking nothing, raising the voltage, 3.3, nothing, 4 volts, nothing, 5, nothing, 7, 8 volts.
Hi.
Do you hear the sound?
Here to help. A little sign in here, a touch of Wi-Fi.
Hey, when I come with the voltage, it's working. Let me go down to 5. Let's see if it's working with 5.
Stay quiet. Just select the little microphone icon towards the bottom of it.
Perfect! But we can be professionals. Yeah, we can be. Now let's do a professional job here. Like usual. Now you have to understand, you can do this kind of, alternative repairs, but you need proper things, yeah, like this one. This is a proper calibrated wire. So what will happen? We're gonna steal some voltage. We need a little bit of flux, yeah, rosin, 180 degree solder wire, perfect. And we are stealing voltage from here. After this inductor or before the inductor. What did you said? You said actually are professional people on the chat and they asked me what will happen with the computer when you put the computer on the max volume? I don't want to know. I mean, for me, it's just, enough to have sound. I mean, we are not benchmarking the audio amplifier, right? Perfect. So we solder the wire there before the inductor. We don't like inductors, right? Yeah, we don't like the capacitors either, but yeah. And we bridge and we send here 5 volts. But you've seen that it was working fine with 8 volts, so I'm pretty sure there is like 12 volts. That's what I think. Now, final test. Yeah, let's plug the power. Pressing the power button and the computer, it is coming on.
Hi there. I'm Cortana.
We have sound!
A little sign in here, a touch of Wi-Fi there, and we'll have your PC ready.
You can hear?
What you plan to do. Use your voice or the keyboard along the way, and if you'd like me to stay quiet, just select the little microphone icon towards the bottom of your screen. If you need
a proper professional job for the guy who support me and buy me a pizza from Domino. You know what? I'm curious, yeah? But listen, I'm proper curious. Leave me a comment and tell me what you will do on this case. How you will approach this repair. I mean, don't get me wrong, the guy wants the computer tomorrow. And I said, you know what? I will have a look today. I promised him, I will check tomorrow and I will tell you tomorrow. So the guy needs the computer tomorrow, yeah? So, yeah, you have to fix it what way you will choose to fix it, or if you'll choose another way. And believe me, I'm learning from chat, from the comments. Just leave me a comment and let me know. Okay, I'm gonna stop here. Dodgy. Someone said dodgy. No, this is not dodgy. What do you mean? Wires are good. I will say thank you for watching. Just like, subscribe if you like the video, and see you on the next one. Bye. Hey, if you find my content being helpful, don't forget you can support this channel by pressing the join button, and you can get instantly access to our members only cool collection and Discord private channels for support with your repairs. Also, you can have a look on our United Kingdom eBay, where you can find some cool and unique products, United States eBay store, or our Patreon page. Thank you.